Hi, Mrs. Haflet. These are my lovely neurons that I designed for you. This one's the presynaptic neuron, which is going to be sending the electrical impulse, and this one's the postsynaptic neuron, which is going to be receiving the impulse. I figured it would be easier for me to just define the parts on the diagram instead of doing it at the same time as I describe what's happening through resting potential and action potential and all of that. So over here, we're going to start with dendrites. The dendrites are these branch-like figures that are coming off of the soma right here. They receive messages from another presynaptic neuron if that was attached to that as well. It receives it at the site of the dendritic spine, which are these like small yellow structures around the yellow yarn. They're all attached to the soma, which is the part of the cell, it's the cell body, which contains the nucleus. The nucleus controls the and maintains the life-supporting functions for the cell. That leads into the axon terminal, which is going to be the structure which emits the electrical impulse out through the axon terminal into the other postsynaptic neuron. The nodes of Ranvier are between the myelin sheaths. Myelin sheaths are fatty substances which conduct the electrical impulse along the axon terminal, and the nodes of Ranvier are spaces between the myelin sheaths which also conduct that electrical impulse. The synapse and the synaptic vesicles are the sites at which the dendritic spines from the postsynaptic neuron and the neurotransmitters, or not neurotransmitters, what is this? Oh, that's the axon terminal buttons, are at the same place, and then the neurotransmitter gets moved from the axon terminal to the synaptic, well, it's stored in the synaptic vesicle, but it moves to the other was I about to say transmitter? It moves to the other neuron. Neurotransmitters are also stored in the terminal buttons. These are axon terminals right here, and then the terminal buttons are knob-like structures at the end of the axon terminal. So there's a bit of a Romeo and Juliet story between the presynaptic neuron and the postsynaptic neuron. This occurs all throughout the body. There are different neurons all over the body which transmits signals between nerve cells. The beginning of the love story starts at resting potential. When there is a negative charge inside the neuron, it is unable to communicate with the postsynaptic neuron, and so Romeo, being the sender of the message, is negatively charged on the inside because he's disappointed that he can't communicate with the exact thing that he's in love with. Depolarization happens, which you can remember the definition by thinking of depotassiumization. That's when potassium is released through the ion channels of the neuron and more sodium ions flow in. So Romeo, the presynaptic neuron, is becoming more positive because he knows he will soon be able to speak or communicate with the postsynaptic neuron because he will be emitting electrical impulses towards that neuron, and he becomes positively charged. Action potential occurs when there is a gaining of electrical energy in the presynaptic neuron because it is going to soon be emitting an electrical impulse to the postsynaptic neuron. It abides by the all or nothing principle, by which it gains a certain level of electricity, and then it stays there at that certain threshold as it travels down the axon terminal into the postsynaptic neuron. So once it does that, and once the neurotransmitter is moved between the synaptic vesicle at the synapse to the other dendritic spine, reuptake occurs, which is where what happens? The neurotransmitter is like retaken. The neurotransmitters are released from the synaptic vesicle site where it's being stored, and then the neurotransmitter gets reuptaken by the synaptic vesicle at that site. And then after that, the neuron, Romeo and Juliet, enter an absolute refractory period because the parents of the presynaptic neuron and postsynaptic neuron, like the parents of Romeo and Juliet, say that they can't see each other once they've seen each other and emitted that electrical impulse for a little bit of time. So the absolute refractory period refers to the space of time in which they are unable to emit any sort of electrical impulses to each other at all. Okay, thank you, Mrs. Hofflet. I hope you enjoyed this love story between the presynaptic neuron and postsynaptic neuron. See you tomorrow, I think. Bye.